Hey Course 3, today we're doing volume. Maybe you've learned a little bit about volume before. I think of measures and geometry, in order. You always get your perimeter first, which is just distance. So the label is just inches maybe in one dimension, and then you always learn area, which is going to be 2 dimensions. So then you start getting, inches squared, whereas before it was just inches. And then once you're ready, you learn the volume of a solid or prism, which means that now you're going in 3 dimensions, finding how much fits into the shape. So with volume, we're finding how much is inside of a 3-dimensional shape. And we find that by locating the base dimensions. We find the area of that. That tells me how many squares, how many cubes, so to speak, fit on this bottom layer. And then I count how many layers there are. 1, 2, 3 layers. And multiply that by the height. And that gives me the total amount of cubes in the whole thing. So it's the area of the base times the height. And to find the base, you multiply length times width with a rectangle times the height. And if it were a cube, right, if these were 2 by 2 by 2, then the volume of a cube would just be then, I guess, side cubed. Just like with an area, it's side squared. So that's how we find volume. And in this case, 18 was the volume. Sometimes you get irregular shapes like this one. Most buildings are not in a perfect rectangular prism shape. To find the volume of a building that's simple enough, where all the heights are the same and all the angles are right angles, they kind of show you how you break that down. You find the area of the base again, then as long as all the heights the same, simple enough. So the area of this base is 144, right? And then you've got a 20 by 15 base, which would be actually not by 15, it's by 27, isn't it? Because there's 15 here and another 12 here. And it gets hard if you don't just, write it down like this. And so it's really 27 across times 20 comes to 540. Add those together to get your total base. 684 feet squared is the area of this entire base. That's one layer of cubes. Then you take that and you multiply that by the height. So you count how many of these layers are there in feet. There are 10 feet, so we count 10 of these layers. Add the 0, 6,840 feet cubed. Remember, it's cubed now when we're doing volume. Okay? Volumes of cubes, 10 cubed if a side is 10. So 3 zeros in your answer there. If we did letter E here, we would need to add up all the areas of the bases. So 2 times 8 plus 8 times 2, I'm seeing. So 16 on this base, 16 on this base. If we draw it flat, it looks something like this. And if it's 16 here, 16 here, I'm counting 32 for the total area of the base. The height is 2. So I'm thinking 32 times 2, 64 centimeters cubed for E. Now what I'd like you to do is none of these problems, but something kind of fun. Find a box from home or in the classroom that's either a rectangle or a cube is fun. Measure its dimensions, length, width, and height. And it says estimate its volume after rounding the dimensions to the nearest inch. To me, you don't need to really round much, but if it's close to 3, like it's 3.1 inches, or I should say 3 and a 16th, then you can call it 3. But I would think you can use the actual dimensions too. Either way, find the volume of a box, round it if you need to, and that'll be your practice to show me the work and the answer on that.